Hey everyone, welcome to this video. Let's talk about transfer learning. So you should be familiar with this diagram we've been using throughout the course for model training, where ultimately we want the best weights possible so our model gives the best outputs or predictions possible. Like maybe a model that's really good at determining if this is a picture of a dog versus a cat. So weights can be thought of as knowledge, or like the brain power of a model, and knowledge can be transferred. And this is pretty intuitive, right? For example, if you know how to code in JavaScript, you will likely pick up Python much faster. If you know Spanish, you will likely pick up Portuguese and Italian faster. And the last example, if you know how to play the ukulele, it will likely be easier for you to pick up learning to play the guitar. So, what are the obvious benefits? Number one, there's less training time, no need to train from scratch. Number two, can provide better accuracy. And number three, less dependence on lots of data, because collecting lots of data for training could be hard and cost more money. So on the top, this is the diagram we've been using for a convolutional neural network. And let's simplify it down to the diagram below. So we still have our learn and extract features, our classification, and we'll just simplify this down to this model is trying to determine if this is a picture of a face, a hand, or a leg. And transfer learning, maybe we will use this model for classifying a face, hand, and leg, or a model that tries to classify if this is a picture of a cat or a dog. And some weights we will update, and some other weights we will freeze and not update. Now, I bet a very quick, obvious question some of you might have is, but wait a second, how would a CNN for face, hand, and leg work for cat and dog? They are both very different. One is body parts, the other are like animals. So how could transfer learning happen here? They are so different. The answer is, well, remember that in the CNN, there is more complex feature extraction as the layers progress. And less complex features, such as curves and lines, are still valuable whether it is for classifying face, hand, leg, or cat and dog, which essentially means extracting features for face, hand, and leg can still be valuable for cat and dog. Now, in transfer learning, you will need to decide which weights to freeze and update. In feature extraction, there's increased frozen weights, which means you rely more on pre-trained model. And fine tuning right here, there are decreased frozen weights, so you rely less on pre-trained model. Let's focus on fine tuning in the next slide. So in fine tuning, there are decreased frozen weights, more weight updates, which means an increased risk of overfitting. And if you do fine tuning on a smaller dataset, model becomes too customized to the dataset and has poor results on new data. So there is an increased risk of overfitting. One way you could reduce this risk is with a small learning rate, which means small weight updates. What I want you to focus on is this. Fine tuning can have better results than feature extraction if you have a larger dataset and are willing to do the extra computation. So here's a table comparing feature extraction and fine tuning, which I will read over. In feature extraction, there's increased frozen weights, so you rely more on pre-trained model, whereas for fine tuning, there are decreased frozen weights, so you rely less on pre-trained model. In feature extraction, there are less weight updates, so there is a decreased risk of overfitting, whereas for fine tuning, there are more weight updates, so there is an increased risk of overfitting. This can be managed using a larger data set, and number two, with a small learning rate. Focus on the last part here. Essentially, for feature extraction, can have better results if you have a smaller data set, whereas for fine tuning, can have better results if you have a larger data set and are willing to do the extra computation. What are some scenarios to avoid transfer learning? The most obvious is different data, right? A model for classifying text reviews, like positive or negative, will not be useful for a model for classifying images, like a dog, deer, or donkey. One works of text, the other works of images. And number two is unique tasks. Maybe you want to classify some unique court documents or unique medical documents, and there's nothing else that exists out in the wild because the documents you have are that unique, in which case you have no choice but to train from scratch. Okay, that's it for this video. Thanks for watching.